We'll go for an activity. Actually, activity is detect the movement or motion in a room to turn on fan, light, and buzzer. Okay, so when someone enter in the room, that time only the light, fan, and the buzzer will turn on. Otherwise, it will be turned off. So it's like a activity to conserve the energy, preserve the energy. Okay, avoid the energy wastage. Okay, what other things we have is like earlier we had a breadboard is there to connect the devices. We have Arduino, a controller. We have a servo motor. It represents a fan. Okay, so motor, motor is actually any actuator which used to run any device like fan or AC or something. We used to have a actuator like motor. Okay, then we have instead of a bulb or light, we have LED. Then we have buzzer to make the alarm. Okay, this is the main thing. The input device, the PIR motion sensor. This is the one which is used to detect the movement or motion inside the room. Okay, all these devices we can get from this area search. So if I go for motion sensor, I will get PIR motion sensor. Okay, I can drag and drop. Then we have buzzer. Sorry, not here. Then remove this. I try buzzer. You will get buzzer here. You can drag and drop. Then we have servo motor, servo motor. Okay, add Arduino controller, Arduino, also there. Everything is here. Just drag and drop. Breadboard also. Just type. Delete this one first. Breadboard is already there. Okay, drag and drop all devices. Then you have to connect. So what about the pins? This is buzzer as we discussed earlier in the activity. 2 pins, one to negative in the breadboard, one towards the signal pin. In the Arduino, it is D4, digital pin 4. Then the breadboard has positive and negative. It is connected to +5 volt and ground from the Arduino. Okay. Then we have a servo motor. 3 pins are there. One is negative towards the negative pin. One is positive to 5 volt. Okay, plus volt. This is signal pin connected to pin number 5. Okay, this is the important sensor or input device. PIR motion sensor. 3 pins are there. The last one is grounded. The second one, the middle one is +5 voltage connected to breadboard plus positive. Then the first one is a signal pin connected to pin number 2. Okay. And what about the coding? So we declare the first thing, the header file for servo. We have a hash include servo.h. Then we have to declare the pin numbers where it is connected. Okay, servo pin. So we put a variable name int, an integer. Servo pin equal to 5. So that means this is connected to 5th pin, right? This one. Okay, servo pin is connected to 5th pin, right? Yes, click left. Okay. Now off time 1000, we declare a variable off time 1000. We need for this for sleep or some delay. Okay. LED third pin. As I connected the LED to third pin. See, LED has 2 connections. Okay, one towards the third pin and it is through a resistor. Other one is grounded. Okay, so that if you don't have this one, no, all the power will go to LED. LED will get burst. That's why you put a resistor. Okay, before giving the connection, the power from the third pin, we give a resistor also. Okay, and the LED has 2 pins. Okay, anode and cathode. Anode is the longest pin, cathode is the shortest pin. Okay, anode is positive, cathode is negative, that you know. Okay, so PIR is connected to second pin. So we put a variable name PIR. It is connected to C. Signal pin connected to pin number 2. Buzzer is 4th, SC. This is connected to 4th pin. Okay. Now setup function means inside that method we will declare the mode of each pin. So LED, I told you, this is output device, this is output, this servo motor is output device, buzzer also output device, LED also output device, and only one input device is motion sensor, which will read or detect the motion. So pin mode of LED comma output. So LED is output device. Pin mode of PIR comma input. This is input device. That's why I put the pin. What is the pin? PIR. What is pin PIR? Pin number 2. Comma. What is the mode? Input. Pin mode of buzzer comma output means buzzer is output device. That's why the pin number or pin name is buzzer, which is having pin number 4 connected to fourth pin. It is mode is output. Its mode is output. Then servo 1 dot attach of servo pin. That means servo 1 is an object. We declare the servo header file. We have an object for that on servo 1. Okay. We are attaching the pin number. Here we are not going to mention that pin mode servo pin com output. We are just mentioning servo 1, the object which we declare. We can give any name. This is the header file. Okay. So inside that we are declaring this is a class, this is an object. Okay. Servo 1 dot attach of servo pin means I am going to attach the servo to pin number 9. Why Mr. 9? Because servo pin is already is 9, right? Where I put here? I put here servo should be 5. Okay, so it is not 9. This header, this one comment, right? 5. Okay, servo pin means 5. So I'm attaching the servo motor to pin number 5. Serial dot begin of 9600 means at a baud rate, the speed of data transfer. Okay, the data transfer rate. Then loop statement means whatever statements we are going to run continuously should be in loop. Okay, so here I'm reading the, I told you the input device is motion sensor, is connected to digital pin. So I'm reading the data from the motion sensor. So digital device means we are going to read using digital read function, digital read off. Inside read capital R of PIR. PIR means the value, the name you give for the motion sensor, PIR. Okay, we read the input from pin number 2. The value will be stored in the variable called as VAL as integer value. I'll print the value by using serial.println. It will be printed in the serial monitor. Here it is printed. Okay, now it is 0, nothing is there. Okay, now delay. So after reading and printing, we gave a delay of 100 millisecond. Okay, now we are checking the value equal to high. The value given by the motion sensor is high. Any that motion is detected. Any the value will be 1. If there is no motion means the serial monitor will show you 0. Somebody moved, if any movement is detected means it will give the values 1. Okay, so high means we are going to turn on the buzzer. As I told you in the last exercise, buzzer, to turn on the buzzer, either we can write digital write of buzzer comma high. What we are doing is we are going to put the buzzer as with a tone and a duration. Okay, this is what digital write of LED comma high means. Now once the motion detected, when the value is high means motion detected, LED should be turned on. So red LED will be turned on high. Servo should, this motor should rotate as per our activity. When the motion detected, fan should run, right? So instead of fan we have a motor. So when the motion is detected now, when the value is high, the motor should rotate. So how it is rotating? We are giving a 90-degree rotation. So servo 1, the object name servo 1 dot function right means we are going to ask the servo motor to move. What is the degree of rotation? 90. Then we are giving some delay of time, any wait for some seconds. Okay, 1000 milliseconds. From where you got 1000 off time, I already declared 1000. Okay, else if there is no movement, value is not high means no turn buzzer means buzzer will not turn on, LED will be low, servo will be going back to 0 position. Sorry, understood? Now I'll run the program. Start simulation. No movement here, that's why 0. Now what I will do, I will click this and I will rotate. See, just move this. Now it is rotating. It was producing sound. In between we had some value more than 0. Okay, now again when I rotate, see it is showing one value here on this monitor. Then it was rotating, and again once it is done, go back to the previous position. Okay, understand?